Today we are going to cover two critical concepts. That's big data and sustainable networks. And also we are going to explore how they intersect to pave the way for greener and also more efficient future. So we start with big data. And again, in our previous lectures, we cover big data and the concept of data mining, data science already. But here, let's just summarize everything here. What is a big data? And we may say that a big data refers to data set that is very large or vast and also complex, that a conventional data processing methods are inefficient to or insufficient to handle them. So we normally characterize big data by what we call the 5 V's. So first will be the volume, and this refers to the quantity of data, which can range from terabyte to petabyte to even zettabyte. So think of all the data generated daily from socials and sensors, transactions, etc. And normally with big data, the volume will be very large. Then the second is veracity. So veracity, this speaks to the speed. Here we talk about the speed at which data is generated and also collected and processed. So in many modern applications, data streams in a real time requiring immediate analysis. So in terms of velocity, we may say the high speed of data generation and also processing. The next is the veracity. So veracity will normally address the quality and accuracy of the data. So with such a large volumes of data can often be uncertain, incomplete, or inconsistent, making, again, veracity a crucial consideration. Also, we talk about the variety. So big data isn't just numbers in a spreadsheet. It again encompasses diverse types of data, and it can be both structured data like database or even semi-structures data like XML files, and unstructured data such as text document, images, audios, and videos. And lastly, of the V's will be the value. So we can say ultimately, the purpose of big data is to extract meaningful insights and benefits. So without value, the other 4 V's are merely an expensive collection of information. So next is why big data matters. And so again, why is big data matters? We may say that big data offers many or numerous benefits, including first, enhanced decision making. By analyzing a vast data set, organizations can make more informed, data-driven decisions rather than rely on intuition. The next benefit can be the new revenue streams. So here, big data can reveal new patterns, opportunities, which can lead to the identification of innovative products, services, and market niches. Next benefit will be the improved efficiency. And here we say optimization of process, resources allocation, and operations also. So improved efficiency allows for the optimization of various processes, from simply supply chain management to resources allocation, leading to significant cost savings and operational improvements. And the next benefit will be the personalization. So companies can use big data to understand individual preferences and behaviors, enabling very highly tailored experiences and services for their customers. And the last will be the innovation. So again, big data forms the foundational bedrock. We can say foundational bedrock of developing advanced technologies like AI, artificial intelligence, and also machine learning, ML, which rely heavily on a large data set for training. However, we can also say that big data also comes with its own challenges. This include some substantial infrastructure costs for storage and processing, critical concern around data privacy and security, a global shortage of skilled professionals, issues with data quality and integration from disparity sources, different sources, and also the complexities of regulatory compliances also. So this can be a few challenges. So that's the challenges. Data storage and processing infrastructure will be an issue. Data privacy and security concerns, lack of skilled professionals, data quality integration, and also the regulatory compliances. So next is the sustainable network. We start with the definitions. So again, this is a very short summary of big data. Next, we talk about sustainable. So let's shift our focus to sustainable network. These are networks, be they be energy grids or transportation system or communication infrastructures that are designed and operated with primary goal. The primary goal here will be, again, to minimize the environmental impact, optimize the resources usage, and also promote a long-term societal well-being. Now, the concept of sustainable network rests on three pillars, as we can see. One is environmental sustainable, with this involve reducing carbon footprint, minimizing waste generation, and also preventing pollution. Next will be the economic sustainable. This will focus on cost effectiveness, ensuring efficient resources allocation, and also maintain a long-term financial variability. And lastly will be the social sustainable. This will ensure the equity, accessibility, and reliability of services for all members of society. So we can say that sustainable networks are crucial for several reasons. They play a vital role in mitigating climate change, also addressing global resource depletion, meeting the increasing demand for service responsibly, and also fostering a secular economic where resources are kept in use for as long as possible. Now, how big data assists sustainable networks? This is our overview. Now, the relationship between big data and also sustainable network is highly synergistic. So big data provide the crucial insights needed to pinpoint inefficiencies, accurately predict demands, and also optimize operation across various networks. So this will empower real-time monitoring and also proactive management of resources and infrastructure. Now, by analyzing vast amount of data from diverse sources, which can be ranging from sensors to satellite imagery, we can make a network more efficient, efficient, leading to reduced energy consumption and minimal waste. Then second will be enhancing the ability to withstand disruptions and adapt to changing conditions. Lastly will be the equitable. Here we say ensuring fair and just access to essential resources and services for everyone. So next is the specific application. We start with our first application, which is energy efficiency. So let's look at some of the specific application here. So with energy efficiency, which is smart grids and renewable integration, data sources including smart meters, businesses, real-time weather station data output from renewable energy generators like solar panels and also wind turbines, and a myriad of sensors is embedded within the grid infrastructure. So data can again come from different sources. So big data application enable predictive demand forecasting. Predictive demand forecasting. And here we say anticipating future energy needs allow us to precisely balance energy supply with demand and significantly reducing energy waste. Now, second will be the optimized energy distribution. And so data helps in routing power more efficiently through the grid, minimizing transmission losses that occur when electricity travel long distances. And also renewable energy integration. Here, managing intermittent sources like solar and wind power become feasible by predicting their output and dynamically adjusting grid operations to accommodate their fluctuating nature. Next and the last will be the demand response programs. And so big data allows utilities to implement programs that encourage consumers to shift their energy use to off-peak. So this will be the off-peak hours, relieving strain on the grid and making it more stable. So the outcome of this application is clear. We want to reduce reliance on fossil fuels, lower carbon emissions, and more stable and reliable and grid operations also. So next is application number 2, which is resource optimization. So first we can say the transportation network. We have transportation waste management. So we start with the transportation network. Here normally data sources are extensive. So GPS data from vehicles, traffic sensors embedded in roads, also public transport schedules, and detailed vehicle telemetry and data provide a comprehensive picture. So what are the big data applications? So here we say big data application facilitate real-time traffic management, also predictive maintenance of vehicles, and optimize public transport. So adjusting bus or train schedules and routes in a real time based on actual passenger demand patterns makes public transport more efficient and appealing. Also by analyzing the vehicle performance data, we can predict maintenance need. Also extending asset lifespans, reducing breakdowns, and lowering the emissions also. So the outcome is less pollution, reduce travel times for commuters and goods, and also more efficient fuel use across transportation sector. So next is the waste management. And here we can say the data sources include the smart bins equipped with sensors that include fullness level. Also data on waste collection routes and information from recycling and processing plants. Next is the big data application about here. First, we talk about the automized collection routes. So the waste collection trucks can follow more efficient routes, reducing fuel consumption and also reducing the operational costs. Then we have the waste stream analysis. Here, analyzing the composition of waste helps identify better recycling opportunities and diverting more efficient or more waste from landfills and promoting a circular economy. Now, the outcome here will be first less waste. So it's less overall waste, higher recycling rates, and also a significantly reduced environment burden. So next is a specific application 3. We talk about environmental monitoring. So big data also plays a critical role in environmental monitoring, particularly for air quality and also climate change, for air quality and climate change. So data sources are incredibly diverse. So IoT sensors measuring air, water, and soil quality, high resolution satellite imagery, and also comprehensive weathercast and various other environmental reports. Now, big data application in this domain also big data application in this domain also can involve the real-time pollution monitoring. Real-time pollution monitoring is to identify the pollution hotspots and their sources in the real time, allow for rapid response and mitigation efforts. Next will be the climate change modeling. Here we're analyzing the vast data set from historical climate record, atmospheric conditions, and oceanic data will help improve climate prediction and also develop effective mitigation strategies. And lastly will be the biodiversity tracking. So here, monitoring the ecosystem and specifies, again, populations provide a vital information to inform conservation efforts and also protect vulnerable environment. Now, we also have a specific application such as disaster management. Finally, let's say discuss a big data role in disaster management. Focus on early warning and response optimization. So the data sources are critical and timely. So detailed weather forecasting, reading from geological sensors for earthquake, or social media feeds, providing a real-time ground information. also historical disaster data, and also the sensor data from critical infrastructure. Now, we know that a big data application allow for predictive disaster modeling, optimize resources deployment, and also damage assessment. So in terms of damage assessment, here we say utilizing the satellite imagery and drone data for rapid, again, post-disaster evaluation. Now, next will be our challenges and consideration. I would say why the benefits are profound. Implementing a big data solution for sustainable networks comes with a lot of challenges. So we can talk about data privacy, and security. That's protecting sensitive information, especially personal data and data from critical infrastructure, is paramount. Next challenge will be the infrastructure cost. The initial investment is scalable in storage, but again, powerful processing capabilities and also high-speed network infrastructure can be substantial. Then we have data integration and interoperability, combining and making sense of data from diverse sources, often in different formats, and also requires significant effort. Then we also have lack of skill workforce, demand for data scientists, analysis, and engineers at the moment kind of low. Then ethical consideration. We have to ensure the fair, unbiased, responsible use of data, and also avoiding, again, algorithmic discrimination. So next is the policy and regulation. Developing appropriate legal and regulatory framework for data governance and also sustainable practices in an ongoing challenge for, again, government, we may say government worldwide. So the future trend, what is next? Looking ahead, the future of data, big data, and sustainable networks. This is exciting. AI and machine learning integration. We are seeing even more sophisticated predictive analytics and the use of automated decision making in network environment. We also saw the IoT expansion. So this will be the proliferation of IoT sensors. And sensor will continue generating even more real-time granular data from every corner of our networks. So the conclusion here will say that big data are characterized by its immune, or I would say immense volume. So big data with its immense volume, velocity, variety, and veracity, and also value. It's not just, again, technological trend, but it is a critical enabler for building truly sustainable network. Also, it provides the intelligence required to optimize resource utilization. Also significantly reduce environmental impact and enhance the resilience of our essential infrastructure. Lastly, I would say that embracing big data is essential for future, where networks are not just efficient, but they are also environmentally responsible and socially equitable. Yeah. So again, thank you for the lectures and see you in our next lectures.